Hello everyone and welcome to KTH. Today in our fourth installment of the weekly series of webinars focusing on the different schools at KTH, we'll look closely at the School of Engineering Sciences. We will have a look at the master programs they offer. We will look at the research areas, the student life and possible career paths that you can take after graduation from the school. So let's get started. My name is Jairam. I work as a communications officer here at KTH and I will be guiding you through the webinar today. I have three guests with me. I'll let them introduce themselves. So let's start with Sandra.
Hi everyone. My name is, as said, Sandra Di Rocco. I'm the Dean of the School of Engineering Sciences here at KTH, and I'm also a professor in mathematics. Which basically means that I do research in mathematics, but I also teach several courses in mathematics, or I should say I used to teach, because now as a dean I don't have that much time. I'm not from Sweden, as you already noticed probably. I'm from Italy. I studied in Italy as an undergraduate, but then I moved to the US for my PhD student. As a PhD student, I traveled a bit. I worked in both in Germany and in the US. And then I came to Sweden about several years ago, 2003, so I've been here for quite a long time.
Thank you, sir. Carlos, you want to introduce yourself?
Hi, Jairam. My name is Carlos Neves. I come from Venezuela, where I obtained my mechanical engineering degree. And right now I'm a student of the Masters in Aerospace Engineering here at KTH, and I am also a student ambassador to the School of Engineering Science.
Great. Martina?
Hi, I'm also a student ambassador. I'm Martina, as you said. I'm from Italy and I'm a second-year master's student in fluid mechanics here at KTH.
Great, thank you. So throughout the webinar, the other student ambassadors from the school is available online, and you can chat with them directly at the link that you see on the screen. So at kth.sc/meet. So you can do that throughout the webinar and even for up to an hour after the webinar. So do make use of this opportunity to talk to the other student ambassadors as well. But we hope that you stay with us for the whole presentation as well. So let's get started. So the School of Engineering Sciences is one of the 5 schools at KTH, and they carry out research and education in physics, mathematics, and engineering mechanics. So Sandra, could you tell us a bit about where this is conducted, the research and education, like in which campuses of KTH?
So we are mainly located in the main campus of KTH, which is downtown in Stockholm, but we are actually divided in 2 parts of the campus. So all the research and education, both in mathematics and engineering mechanics, is done and takes place close to the main entrance, so actually very close to here where we are right now. But all the physics and applied physics research and education takes place a little bit north, actually not so far from here, in a place that is called Alba Nova. You see there at the top part of the slide, in a building that is called in fact the Physics Center, and it's a building we share with Stockholm's University.
Great, thank you. We at KTH are really proud to be ranked top 100 in the latest QS rankings. Sandra, so could you tell us a bit about the different rankings for the subject areas within your school?
Yes, and we are extremely proud about the 3 subjects that our school represents, because as you can see, I mean, the numbers are very small, which means that we are very high in the ranking. So as you see, mechanical engineering is number 25th in the whole world, and mathematics 49, and physics and astronomy number 90. This is something that has been growing during the last year, and we are extremely happy about it.
Yeah. Was this a factor for you guys to choose KTH, Martina?
Yeah, personally it was essential for me when I was applying for my master's degree. I only looked at the top 100 globally, so 25 sounds pretty good.
Well, yes, of course. Everyone wants to be in a top university, and if you look here, at least in mechanical engineering, KTH is 25th, but if you filter out the university in Europe, it is in the top 10, so it was a factor that it was important in my application and my selection.
Thank you. We are also proud to be ranked 41st worldwide when it comes to sustainable development in the Times Higher Education Impact Rankings of 2021. The Sustainable Development Goals are integrated in all our master programs. And maybe Sandra, you could tell us a bit about how your school worked with the SDGs?
Yeah, well, it's quite an intense work. It's still a work in progress, I have to admit, but we have been working quite intensively during the last few years. It's one of the main goals of KTH. And what I can say is that every master program has a pretty much clear path among this actually 17 sustainable goals. So there is a clear way to build your education among all these goals.
Yeah. Carlos, do you have any examples of how it's integrated in your program?
Yes. KTH is pushing for sustainability in all of those programs, and that is something that you might find in some courses throughout your education. As an example, in aerospace engineering, we know that airplanes and rockets are one of the machines that are polluting the world at a great extent, and we are aware of the situation, and these are topics that we also studied while studying these kinds of machines and applications in our career.
Okay. Thank you, Carlos. So the School of Engineering Sciences offers 10 master programs that are taught in English within the areas of engineering, mechanics, physics, and mathematics, as we mentioned earlier. So all the programs are in English, as I said, and then these are 2-year programs. We also have 2 programs which are jointly given by KTH and another partner university, usually in Europe, but I think there are some programs which can be from outside Europe as well. Sandra, so maybe you could tell us a bit in detail about these programs, and maybe we can start with the area of mathematics.
Yes, thank you. Well, I might be a little bit longer on mathematics, in mathematics, because it's my area. You might excuse if this happens.
No problem.
It's only natural, I think. But in mathematics, we have actually 3 different master programs that we offer. The biggest one, I would say, it's the one in applied and computational mathematics. Which has several specifications, as you can see in the slides, or tracks, as we call them. So we have one in actually computational mathematics, one in data science, which has been recently added just a couple of years ago. One which is extremely popular in financial mathematics, and one which is also very popular, optimization and systems theory. Then we have a master program that we call mathematics, which is a joint program with Stockholm's University. So there is a double degree there as well from KTH and Stockholm's University. And it's a program in mathematics, meaning more theoretical mathematics, even though there are some applications involved here as well. And then we have a more international program, as I could say, which is a program in computer simulations for science and engineering. This is a joint program with TU Berlin and TU Delft. So here is also, so our students get also a double diploma from KTH and their original university, which could be TU Berlin or TU Delft. And this is, of course, a program about simulations and mathematical modeling, I would say. Right. So this is about mathematics. Yeah. We can shift to physics. So in physics, and here is both physics and applied physics, we have two master programs, as you see from the slide. So one is called a program in engineering physics. This is a broad program. Actually, the students here prepare themselves with quite a deep understanding of theoretical physics, but also with a good attitude towards applications, I would say. There are some interdisciplinary components in the program, so it's quite exciting. The program also comes with the different tracks and different specialization, as you see from the slides, going from biomedical physics, so this is very applied, one could say, or with applied perspectives, to theoretical physics. This is the last one, but then we also have optics and photonics, quantum technology, and subatomic and astrophysics. Then we have a second program in physics that is called the nuclear engineering, nuclear energy engineering, which has many specializations. I will not read them all. I think you can see them from the slides. This is quite an exciting program. As Sweden, in general, I would say, is one of the exciting country when it comes to actually climate-friendly actions, and when it comes to energy. I just can mention that in Sweden, when it comes to friendly electrical energy systems, this is one of the most exciting part in the world. At the moment, we have like 50% actually hydro energy, 40 to 45% nuclear energy, 5 to 10% renewables energy. And when I speak to, when I mention 50% actually nuclear energy, it's important to have a very good research going on and education going on. And in this master program, actually, there are a lot of courses and a lot of knowledge that is built up in this area. Yes,
we can look at
we can
mechanics.
then, exactly, thank you. We can go to engineering mechanics. Here we have a broad spectrum of master programs. You see there are 5 of them with quite a lot of specializations. I can say just a few things. So in all these master programs and in all these specializations, what it boils down to is to build up the models and the basic knowledge about movement. So movements that could be underwater, on surface, on Earth, in the air, in space, for example. So even in all 5 master programs here, there is a very big interdisciplinary component. At the same time, a broad education in for example, fluidodynamics, fluidomechanics, and this. Subjects. But since we have 2 representatives from this area, I wouldn't mind
to. So maybe we can start with you, Carlos. How is your program? Can you tell us about it?
Well, yes, in the Aerospace Engineering Masters, it is divided in 4 different tracks: lightweight structures, aeronautics, space, and systems. And there are many possibilities, and there are many courses that you can take to be in a specific kind of engineer that can actually take you to your dream job. But basically what we are studying here are control systems for aircraft and rockets as well, aircraft or any kind of vehicle that is traveling through the air, and also the structures in them.
All right, thank you. Martina, how's your program?
Right, so I'm in the engineering mechanics program in the fluid track, and I think among all the options in the engineering mechanics department, the engineering mechanics, especially the fluid one, is the most theoretical one, I would say. You have opportunity to study applications. For example, we have exams in wind energy aerodynamics, which is also connected to the sustainability that we were talking about before, or vehicle aerodynamics, but most of the courses have a very strong theoretical basis that's the main focus of the course, and that's why I like it so much.
I'm a bit curious of why you chose the program. Like, what's your background and why did you choose your program?
Well, basically I'm a mechanical engineer and I love aerodynamics. I love fluid dynamics, and here at KTH has a really good program with different courses that can actually take you to that specialization in aerodynamics, at least in the aeronautics track, and that was basically why I chose this track in this program here at KTH.
And what about you, Martina?
I think a good difference between me and Carlos that I would like to mention is that maybe the aeronautics track is more about the application and the practical side, while the fluid mechanics is still aerodynamics and fluid dynamics, but it's very theoretical. And I'm a graduate of aeronautical engineering at the University of Glasgow, and I've always liked fluid dynamics and aerodynamics, but on a theoretical and research point of view. So that's why I chose KTH, who offers one of the very few masters that focuses only on aerodynamics and fluid mechanics, so worldwide. So yeah,
okay,
pretty good.
Thank you. So now maybe we can look closer at the research departments within your school, Sandra. Could you introduce that for us?
Yes, well, I can say that as actually Martina and both Martina and Carlos already mentioned. I mean, the research and the 4 departments have a very broad spectrum in their research areas. So we both from very theoretical aspects to very applied aspects. So from the theory to the doing. So there is room for the people asking, actually, for the people appreciating more the theory, or to people appreciating more the applications. And actually, it is important that the 2 components are present, because theory is important for having applications, and applications is important in order to develop the theory. So this is actually one of the strengths of our school, that we have 4 departments where the whole spectrum in research, from the very basic research to the very applied and industrial inspired research, I would say, is present. And this is in all 4 departments, I would say. And this aspect is also reflected in the work for a master thesis. We have very good connections with several big and smaller companies in the Stockholm areas, but even international. I could mention Volvo, I could mention Ericsson, but also very exciting smaller innovation companies. As you probably all know, Stockholm and Sweden is one of the biggest innovation cities in Europe, certainly, but I would say even worldwide. So when it comes to a master thesis, our faculty can offer this choice. One can have a pretty theoretical work, sometimes even publishable in research journals, but also a quite down-to-earth application directly with the industry, and this we see actually it's very popular.
We can look at some examples.
Yes, I prepared 2 slides. This is more, I wanted to explain what it means for us to analyze things and to do research in certain areas. So as I said, I come from mathematics, and actually I am a very theoretical mathematician. At least I was born as a very theoretical mathematician. Then I came to KTH, where I actually realized that it's very exciting to actually look at certain applications and even use your very theoretical background to advance in these applications. So I want to just take a few minutes to talk about data analysis. Data analysis is very popular right now. It's very important to analyze data because we accumulate a big amount of data. Big can mean actually big in terms of volume, so a lot of data coming from experiments or often direct observation. But big can also mean complex. So we can have a small volume but complex in itself, statistically complex, that needs to be analyzed. So what does it mean to analyze data? And what is data? Well, data, if you think about information, when you gather information, think about, for example, clinical information, you gather certain observation numbers. So you might attach to one patient a certain row of observations about his or her temperature, a reaction to a certain medicine, and so forth. So you have a row of numbers. Well, when you have a row of numbers, so if I would present to you a pair of numbers, I hope all of you would think about a point in a plane, because these 2 numbers can mean 2 components. If you don't immediately think about it, I'm telling you to think about it right now in this way. So it's a dot in a plane. If you want a dot on a board. If you know a little bit about, or if you have ever seen a painting from the Impressionist time, so an Impressionist painting from the Impressionist movement, this painting is made of dots. Okay. But of course there is color. There are colored dots. So these colored dots form a picture. But if for a moment you think about the painting without colors, suppose that you cannot see colors, so you just see dots on this board. So this is the picture that you see on the very left, very dark. Well, this is big data. This is a lot of information, and of course, two-dimensional one, but it's a lot of information, and you really don't know what to make out of it because there is no color. Analyzing data means giving color to this amount of dots. So if you start with this dark painting, and when you develop a meaningful and effective analysis, then you come up with an image, and this image tells you something, and that's what you want to actually grasp from a data, some information in order to actually apply this data in a meaningful way. And this is what we try to give actually when it comes to data analysis, but also when it comes to actually mathematical modeling, and even when it comes to reasoning. You know? We have to build a way of analyzing. Building a way of analyzing data means finding maybe a new way, new formulas, new algorithms. So we can go to the next slide, where I just try to convey one point, that theory is important and applications is important, and that's why a master program at KTH with this kind of environment could be exciting. So if you look at the first picture on the left, this robot. You can imagine this robot as a robot arm. So you have a hand at the end, and then you have certain number of bars that constitutes your arm. In this case, my arm would be just 2 bars, and these 2 bars are attached by a joint, and this joint can in fact rotate and move in space, right? But these more complicated ones have more than 2 bars. You know, there are the very important ones in kinematics, studied a lot in kinematics, have typically 6 bars, 7 bars, or 8 bars. And a meaningful question that is actually quite important in kinematics is, given a point in space, so a point say here in space, how to actually build this sort of robot arm with 6, 7, 8 bars that reaches this point in a meaningful way and in a doable and effective way. Well, you can actually model this robot arm in a very specific mathematical modeling, and this is a geometrical mathematical modeling. This is the picture in the center. And then this question is about in how many ways you can build this model. Well, if you choose 8 arms, 8 bars, sorry, not 1 arm, 8 bars, it turns out that there are infinitely many ways of building this. So how can you analyze this program? You have infinitely many dots. Infinitely many dots can mean many things. It can mean a one-dimensional, because if you think about a curve or of a line, you have infinitely many dots. But it can mean also two-dimensional. If you think of a surface, this table also has infinitely many dots, and so forth. Well, it turns out that, and it's in fact mathematics that tells you that this infinitely many dots can be arranged in a surface, and that's the surface on the very end, on the last picture. So analyzing this surface, the geometry, the dots, how they are, it actually gives you an answer to this very, very mechanical and engineering problem that we started with. And this is something that you might be able to understand and do after a master here at KTH, for example.
Really interesting examples. Thanks, Sandra. So I just quickly also want to mention that the first Swedish astronaut in space, Christoffersson, is actually a professor at KTH. He's also KTH's alumnus, and he's the director of the KTH Space Center. He teaches the course in human space flight, so if you happen to take that course when you're here, you might get to meet him as well. So I just wanted to mention that. And moving on. Many of our graduates are interested in doctoral studies. So I don't know if you have any like maybe some, let us know how it's structured here. I'm curious about that, like how doctoral studies are structured here at KTH.
Well, KTH has several doctoral programs structured similar to a master program, but they are longer. We have many graduate students. I should mention there are over 20,000 graduate students here at KTH, many at our school, and the doctoral studies are pretty much between 4 to 5 years. 4 years if one only devotes its time to research. So we say 100% to research, but typically is not the case because everyone would like to have some teaching experience or some other service in the department. So we stretched actually this time to 5 years. We have a lot of PhD programs. In our school we have 8 PhD programs, pretty much in physics, mathematics and mechanical engineering.
Yeah. Martina, you said that your program is very theoretical. Is this something you have considered after your graduation?
Yeah, definitely. My ultimate goal is to become a researcher, so a PhD is kind of mandatory at this point.
Yeah, wish you the best in that pursuit. Moving on. So KTH graduates, as you can imagine, are highly attractive in the job market, both in Sweden and across the world. KTH was ranked 70th globally in the latest QS graduate employability rankings. From our latest career report, we saw that 7 out of 10 graduates said that they got their dream job after a degree from KTH. We also saw that around 50% of our graduates actually received a job offer even before they graduated. But of course, we recommend that you finish your degree and then start your job, of course. We also see that one of the most common pathways to find your first job is actually through the degree project that I think Sandra also mentioned a bit earlier. So yeah, students do this in their final semester of their studies, and then that's a great pathway to your first job. Sandra, so maybe you could tell us a bit about some common career paths for graduates specifically from your school.
Yeah, well, on the slide you see a long list of career paths. This is taken from a survey from our alumni that we do every other year. I don't want to comment on each of these career paths, but you can see the broadness of the choice. We go from financial related paths to core engineering jobs. Of course, there is the job as so many people stay in academia. So you can be a researcher, a professor, a PhD student as well, a financial analysis, data analysis. It's increasing in recent years, and again, what this list shows is that you can have a big choice after your career, and there is actually, it's not really extremely important that you choose it at the beginning of your master. I have PhD students in pure mathematics who are now data analysts or I don't know, working at Ericsson. I have 2 working at Ericsson. So it's the knowledge that is important.
Yeah. Carlos, do you see any possible career paths in this list?
Well, yes, especially if we see the list in the slide, there is a CFD engineer, and this is something that I want to become. Since I like aerodynamics, I want to be an aerodynamicist, and I want to be able to handle the tools to be a CFD engineer as well. And this is something that can actually lead me to my dream job, that is being an aerodynamicist in the Formula One. And this is something that I think that I can achieve here in KTH, because if you even go to LinkedIn and you check the profiles of teams like Mercedes, Aston Martin, Williams, you will find graduates from KTH in those teams. And I can even mention that 2 months ago, AlphaTauri was looking for an intern here in KTH. So.
And Ferrari.
AlphaTauri. AlphaTauri.
Great. Okay, I hope you find your dream job as well, Carlos.
Yeah.
So now you started your studies earlier this autumn. So how has these first few months been for you?
It's been kind of special. Here you can find some examples of my life here in KTH in the slide. In the bottom 2 pictures you will find 2 projects that I conducted in my first courses, and you will see that KTH is an example university where you can have hands-on experience in your projects. Here you find a rocket project where we actually use the rocket equation to build a rocket from recyclable materials, and it was kind of fun because it was like a competition among the teams in our course. And this is something that is also relevant here in KTH, that all the courses are focused into teamwork. And you're not only learning to be an engineer by yourself, but to be an engineer as a part of a team. And this is something you will be developing in all of the courses. I also have here a picture of my glider project in the flight course where we were given the tools to study the stability of gliders and aircraft, and we were able to build a glider from balsa wood, and it was also competition among teams in the course, and it was pretty nice. In the other picture you can see my accommodation here in KTH with my flatmates, and it's kind of amazing. It's kind of amazing living here in KTH, and not everything is about work. Here I also have a picture about the kanelbulle, about the fika culture that we have here in Sweden, and these are one of the best desserts that you can actually have here in Sweden and probably in the world. And if we go to the other slide, we can actually see Stockholm, not only in KTH, but the surroundings, and everything is so beautiful. The architecture is magnificent, and you have a lot of places where to go. You have a lot of touristic places. You will be inside of an international environment. And if you want to leave the university just to get away from the studies for, I don't know, 2 hours, 3 hours, you have a lot of nature surrounding the University of Stockholm where you can take really great walks with friends and see maybe animals, Scandinavian animals. Here there is a picture of Skansen, which is a zoo where you will be able to find Scandinavian animals. And even if you're walking throughout KTH, you will be able to see deers or rabbits, maybe during the night. So it's a real nice place where to be.
Great. Sounds like you have had a great first few months.
Yeah.
And Martina, you have been here more than a year now.
Yeah.
And how has that been?
It's been good. You can see from my slides, I'll talk about the first one in a bit, but the second one specifically, the difference between the aeronautics track and fluid mechanics. That's our first project. We had a competition. We had to build the tallest tower with spaghetti, a marshmallow, and some tape. Yeah. It was fun. The first one is actually one of the first things that I noticed of the KTH main campus. There's this sculpture of vortex shedding von Karman Street, call it whatever, which, I don't know, to me felt like I finally arrived to the place where I was supposed to be because of my love for fluid mechanics. There's a whole sculpture about it, so I was like, yeah, it's important. Yeah, on the right you can see me studying during the pandemic because I studied it here last year. And on the bottom of the slides you can see the two pictures on the left-hand side and the center is a picture taken of the same place, which is Lapis Beach. Lapis is one of the student accommodations here in Stockholm. And the left one was taken at midnight in June, and the right one was taken in January, I think. Probably in the morning because here it's dark pretty early in winter. And the last picture is it's a picture that basically all of you will have at some point in your phone because it's one of the best viewpoints in Stockholm.
I also have it.
Yeah, that's probably everything about life and now real life. So I worked part-time during my first year and I'm still working part-time, so that's what you see on the left. And I work for Velov. So again, Stockholm is big on sustainability, and Velov is actually one of these startups, and we deliver parcels by bike to reduce the carbon emissions that from cars, for example, and vans. It's one of the easiest jobs to get, so if you're thinking about working part-time, it's a bit challenging physically speaking, but it's a good exercise. You don't have to pay for the gym, you know? So yeah, that's me. I was waiting for my manager because I got a flat tire. It happens. And on the right-hand side is a very realistic and accurate description of me at the moment, trying to do maybe too many things at once. I still have courses and exams. I'm working on my final project and I'm working part-time. So small tip, don't start your thesis while you still have courses because yeah, it's gonna be messy. I'm doing my thesis with an industry, as Sandra was talking about before. It's a possibility that's very common here at KTH to do your thesis in conjunction with an industry or a company. This is a German company regarding wind farms. And yeah, my project is about a validation of a new model for my aeronautical engineering, aerospace engineering fellows.